Hello and welcome to Automation Fair. We're here in Rock Studios this morning, live from the show floor, to talk a little bit about the really exciting partnership and the work we're doing together between Rockwell Automation and NVIDIA to create the future of industrial automation. I'm Christine Spella, Senior Director of Integrated Marketing at Rockwell Automation, and I'm excited to welcome you with us. I'm going to encourage you to make sure you're talking to us, typing your questions in the chat throughout this live stream, and we're going to get started to have this great dialogue. So here with me is Bren Brandewie, Global Lead of Partner Management at Rockwell Automation, and Julie Steiner, who is our Omniverse Strategic Alliances Manager at NVIDIA. So thank you guys for joining me.
Yeah, excited to be here, Christine.
Thanks for having me.
And for those of you that are watching, please stay tuned for immediately following this broadcast. We're going to cut live to a fireside chat between our Chairman and CEO, Blake Moret, and NVIDIA's Vice President of Omniverse and Simulation, Rev Leberidian. So that's going to be a great segment too. So as we get started here, Ben, can you talk a little bit about what makes this partnership so exciting and what we're doing right now together?
Yeah, absolutely. So it really comes down to the fact that Rockwell is a leader in industrial automation and NVIDIA is a leader in AI and high-performance computing. We have complementary capabilities that can solve manufacturing's biggest challenges. Manufacturing is a $15 trillion market, lots of opportunities for value creation. However, it is constrained by supply chain, cost pressures, and an aging workforce. All of this calls for a need for enhanced automation. This partnership really bridges the gap between industrial automation and emerging technology, really positioning both Rockwell and NVIDIA to lead next generation smart manufacturing, driving productivity, innovation, and sustainability.
That's awesome. Julie, share with me a little bit from your seat with NVIDIA what you think about the partnership.
Yes, absolutely. We're now seeing a shift from industrial automation to industrial autonomy with AI applications at every layer of the technology stack and across the life cycle. All of which is serving to bring AI as close to the process and as close to the user as possible to drive value from design to manufacturing through operations.
That is absolutely true. So we had an exciting announcement earlier today between NVIDIA and Rockwell Automation. Talk to us a little bit about this announcement and about the innovations we're driving with Emulate 3D Factory Test.
Yes, Emulate 3D's factory test, planned for early 2025, will enable an NVIDIA Omniverse powered visualization of true factory scale digital twins through a web app. Engineering teams of different disciplines use Emulate 3D to build dynamic digital twins of a piece of equipment or a single production line. And they're connected, of course, to their specific control systems and HMI to perform functional testing of each section model. Now, most of the issues arise in the boundaries between these twins as they get combined together. With factory test enabling these various models to be combined and visualized at scale, we can now carry out system-level testing in the virtual world and resolve all of these boundary issues before we even get to the factory floor.
That's amazing. So we often talk a lot about how do we simplify complex problems for our customers. Ben, talk to me about how Emulate 3D Factory Test is going to simplify the experience for customers.
Yeah, absolutely. So when I think about how these innovations help manufacturers, it's good to take a step back and think about, manufacturers produce a tremendous amount of data. We know this, and according to McKinsey, this data amounts to around 1.9 petabytes of data per year, which I don't know if I can conceptualize that, but that is roughly 2 times the next closest industry. So it's a tremendous amount of data, and the challenge is really utilizing that to improve our customers' outcomes. How do we take that data and make our customers have better solutions and outcomes? So with factory tests, not only can we virtualize a full factory digital twin, but we can connect to other systems in this environment and by extension, drive the results of that simulation. Emulate 3D, as we know, already able to connect to manufacturing data sources. Everything from the obvious in our PLCs to Plant PAX distributed control systems and Factory Talk Batch, etc. Once E3D connects to PLC, connects to a PLC to replace the need for physical hardware, the rest of the automation system above the PLC is really able to be simulated and tested with minimal disruption. So it's as if it was connected to a real plant.
So, real plant, real problems, real solutions. Let's talk about a real world scenario. Like let's give some real examples of how this is going to help improve our customers' experience.
Absolutely. So I'll kind of think about the keynote that you referenced, a brilliant keynote we saw this morning. So if you imagine a consumer products company launching a new soap factory, before that plant is commissioned and begins producing product, the plant manager might want to see that factory running virtually, the entire factory at once. They want to be aware of all the variables that can alter production or even cause problems. Factory tests can allow that plant manager to see and test the entire plant in one single environment as opposed to line by line. It can also allow them to collaborate with other plant personnel or headquarters in real time. On top of this, the rendering that Omniverse provides can give a photorealistic feel that can enable some fascinating use cases. For example, maybe the plant manager has new hires using this rendering. They can then get acquainted with their new environment before they ever step out onto a live production floor. These advanced graphics also obey the law of physics, which is really important to understand. It's to the point where they could potentially be used for pre-training of vision systems, other AI agents within the Omniverse environment. By rendering our simulation to more accurately represent the real world, this allows customers to address other use cases at all points of the project lifecycle. Demonstration, simulation, emulation, commissioning, operator training, even advanced analytics applications. So you get the idea.
That is awesome. I love when we can make it really tangible for folks. So Julie, we're talking about this partnership between NVIDIA and Rockwell, two leading experts in different sides of the house, right? So talk to me a little bit about what the next innovations and why this is so important for these two companies to be partnering together now.
Yeah, absolutely. NVIDIA was created to solve the world's biggest challenges, and the next wave of AI is industrial and physical AI with an expanded view of robotics and robotic systems. We have to teach robots how to operate in our world, including our factories. Rockwell's wide industrial reach and dominant North American PLC market share make your customers some of the largest generators of industrial data. Now, we're starting with foundational building blocks, full factory digital twins, and accelerated compute, because as lines scale system level, digital twins require more computational power to avoid bottlenecks. Our next steps are to enable physical AI, or AI in the physical world, using advanced simulations and learning methods to enhance the ability of robots and infrastructure to perceive, reason, navigate, and act. It's actually amazing when you think about what these two giants of technology and innovation can do together.
I can't wait to see what's going to happen next and what the next announcement that we're going to be able to bring to market together is going to look like. Well, I hope everybody has had a little bit of insight, and as a result of this session, I want to thank Julie and Ben for joining me here. And I want to take a moment to make sure that everybody knows there's a link in this video post that will take you to more information about this great partnership. And don't forget, stay tuned because we're going to go straight to a live fireside chat between Blake Moret and Rev Leberidian in just a moment. So thanks for joining us.
Well, good morning, everyone. Thrilled to spend a few minutes with Rev, talking a little bit about the role of AI in industrial automation. You know, we've spent a lot of time talking here and demonstrating on the show floor really how we're creating the future of industrial operations. And at dinner last night, talking to really a diverse representation of different types of industries, it was remarkable how big a role that artificial intelligence plays in each of their visions of what their operations could look like.
Yeah, what we're experiencing right now with the introduction of artificial intelligence may be a little bit discombobulating and confusing to some. But in some sense, it's actually quite simple. A little over a decade ago, with the invention of this new kind of software development, what we're calling AI or machine learning, we introduced the possibility of solving computing problems, of creating software and algorithms that we had no way of creating before. We had been trying to solve problems like image classification and computer vision for decades, and had just failed to do so in a robust way. All of a sudden, with this new invention, the concept of having software write the algorithms for us by us giving it lots of examples of what we would like it to do, we now unlock the possibility of creating algorithms we just didn't imagine we'd be able to do beforehand. And where we think that this is going to be the most applicable, where it's going to be the most valuable, is in applying this computing to things related to the physical world around us, to the world of atoms, not just the world of ones and zeros and knowledge work. That's why we're so excited here to be here at Automation Fair and work with Rockwell to connect the world of computers, algorithms, and the power of AI and this new kind of software to the physical world through the bridge that Rockwell provides.
Yeah. You know, and when we look at opportunities for where Rockwell is focusing our efforts on artificial intelligence, you know, you mentioned the word, and it's simplification. A lot of the things that we're applying AI to are to simplify the whole business of designing systems, to be able to commission those systems through simulation, to be able to operate and maintain them in a predictive way. You know, you talked about machine vision, and I can remember, you know, old use cases where it was just too hard to hard code the classification systems for sorting tile or looking for imperfections on a metal painted surface and things like that. And AI really gives us that opportunity to be able to take a frame from whatever camera is being used, but to look at it as a very sophisticated sensor and to process it at speed on a line or in a piece of equipment. So really simplification, I think, is that common thread. Another example of simplification is on display at the show, and that's use of co-pilots to be able to allow an operator or an engineer to use natural language to program Logic's controller. So this is a real-world example that's here today. People say, is this in the future? No, it's here today, and it's going to allow people to not have to worry about the arcane syntax, you know, of ladder logic if they prefer to program using natural language and to pull from models to be able to take library code and to put it together. So I think there's a lot of examples. And another one is the subject of the recent announcement that we made about our collaboration, and that's really use of embedded APIs within our Emulate 3D simulation tools to be able to transport those models to the Omniverse.
Yes, we're very excited about this collaboration, and what NVIDIA does fundamentally is we build computers, we build computing systems, we build core technology, but we don't build applications and solutions ourselves. For that, we rely on our partners, our ecosystem partners, such as Rockwell, to take our computing technologies and actually turn it into something useful that solves real problems for others. We deeply believe in the power of simulation and the simulation of physical things as a company because we use simulation ourselves to build our chips. We've been using it since the very beginning of NVIDIA. We're about 32 years old now. Before we tape out our chips, before we send the file that represents all of the design and the transistors and layout of the chip for it to be fabricated, we have simulated it in every possible configuration, emulated actually running applications on that, so much so that we're certain that when that first chip comes back, it's going to work. And it's really the only way we can build such a complex thing. We have billions and billions of transistors in there. It's so complex, it's impossible to have thousands of designers get it right the first time without first testing it inside a simulation environment. We believe the same is necessary for all things we build in the real world. And the things that we're building in the real world are becoming more complex, especially as they become imbued with more computing, with more intelligence. The factories we're building, the warehouses, the products themselves are becoming more and more complex. The only way we're going to be able to do this right, do it efficiently, have good time to market, not waste materials and energy, is by ensuring that the way we do it is done well from the start, and that's through simulation. So what we're building with Omniverse is a core set of technologies that allow us to build large-scale simulations that leverage the computers and the computing systems that NVIDIA is good at building. And we're integrating that into Rockwell's applications and technologies. The first one is Emulate 3D. Very, very exciting, because we think that this is not just a nice-to-have thing, but it's essential for us to get to the next wave of the next industrial revolution, which is all about automation and applying intelligence to the complex systems we're going to build.
Yeah, interest really accelerated in this technology during the pandemic, because if you think about the commissioning process, in the example that was being shown in the graphic of a bottling line, for instance, whether it's soap or soda pop or beer, you couldn't have at that time people, representing, each of the pieces of equipment, decal, conveyor, labeler, filler, bottle washer, all the different pieces of equipment, probably from different companies. It just physically wasn't possible that you were going to be able to bring everybody shoulder to shoulder in a normal commissioning process. And so the idea of being able to remotely commission and to develop digital twins of the different pieces of equipment, being able to aggregate them, for instance, in the Omniverse, is something that people started recognizing because it was necessity to be able to turn to digital tools there. And so we're seeing companies like First Solar, as they're using Emulate 3D to debottleneck their lines making solar cells, solar panels. You see UPS, as they embark on their digitization journey and their operations, looking at using Emulate 3D and talking with NVIDIA, and we had some conversations last night. And so you see it across a really diverse group of vertical industries and different users, equipment builders and users, who are recognizing that simulation can save time, it can pull the commissioning to the left, so to speak, on the project timeline, and you can work out different options of workflow digitally. Think of it as in a gym, as opposed to wasting huge amounts of material, physically having to try it out. So we're seeing it here, and a lot of the technologies on the show are proof that this is really catching fire. I guess, you've also talked about some of the other issues from a technology standpoint that makes simulation interesting. You've mentioned before when we've talked about the 3-computer problem.
Well, this fair that we're at is about automation, and where automation is going is autonomy. Up today, most of the automation we have is kind of a fixed set of systems that are coordinated kind of explicitly. But increasingly, what we're going to have is components inside these systems that are autonomous, that are kind of thinking for themselves and adapting to the situation around them. It's essentially agents in the real world, or robots, that can do a few things. What a robot is essentially is a system in the real world that can perceive the world around it. It can use computer vision and a set of sensors to kind of understand what's going on, make some decisions, and autonomously plan what it's going to do, and eventually actuate. In order to build these systems, we need a lot of technology, and we need 3 types of computers. Mostly when we think about robots, we think about computing in the context of robots. We think about the computer that's in the robot. There's the computer inside an AMR, or the one that's driving a pick-and-place arm, or a self-driving car is the type of robot that you might think of. But in reality, that's actually the last computer. When building and operating this robot, before you can use that computer, you need to develop the software that's going to run on that computer, essentially the brain of the robot. And for that, today, with the new way of developing software through machine learning and AI, we need a very different computer to generate the brain. We need an AI factory. So that's our second computer, is the AI factory computer. But the lesser known computer that you also need is a computer that can simulate the world that the robot is going to operate in as accurately as possible, as close as possible to the real world, so that you can feed life experience or data into the AI computer in order to produce a good brain. Before we put this brain into the actual robot computer, you want to make sure that this brain operates properly. We need to test it inside a simulated world. So in order to create these new systems, we essentially need these three computers. You need the simulation computer, which is the environment in which the AI brain is going to learn. You need the AI factory computer that is going to produce the brain from that simulation environment. And then finally, you have the computer that actually operates the physical robot, where you upload the brain that's produced from the AI factory onto it.
Yeah. Well, and because of the immense amount of compute that's needed, it's no coincidence that one of the early implementations of NVIDIA GPUs and Rockwell's systems are in our mobile robots, right? Being able to perceive the environment, being able to plan the route, being able to send that information up. And so it's an opportunity for us to learn how to do that processing, and in a pretty advanced neck of the automation woods, if you will. And I think that's just going to expand, because if you can collapse the number of separate compute surfaces that you're using in automation problems, you're simplifying. And if you can still get the performance and you can introduce the autonomy that you mentioned, so that it's not just closing a loop of inputs, logic, and outputs, but you're also being able to learn and to be more performant with time, then that's pretty exciting, and we see that as a real opportunity. Now, I think the other aspect of this, of course, is the workforce capabilities, because what we've seen in some early implementations of Emulate 3D is you need to, as a manufacturer, do it like you mean it. If you take somebody who's in their day job programming in traditional ways, programmable controllers, and you're not giving them the time and the resource and the enablement to get comfortable in the simulation environment, you're not going to move as fast as you would like to. And we see that in multiple locations. And so really taking the right steps to enable the workforce to be comfortable with this technology is important. I'm sure you see that all the time.
Yeah, I think in terms of this technology, it's really unique in the history of computing, in that the more advanced this technology gets, the easier it is to use. That hasn't been true for most of the other technologies that preceded it. What you were speaking about earlier with using natural language to help with programming through logics and computing languages, up until recently, if you want to write a computer program, tell a computer what to do, you have to study a lot. You have to go do a lot of work to understand how a computer works, how computer languages work, and how to make them do these things correctly. But we're in an era now where we can speak to a computer with natural language, tell it what to do, and it translates our intentions into an actual program. It's not perfect yet, but it's actually pretty good already. And it's getting better and better. And it's not going to be long until essentially every person on Earth is going to be a computer programmer, because they can program just by instructing a computer in the way they talk to any other human, any other agent that walks amongst us. So I think this is the right time for everybody to take a step back and look at what does your company, your systems, your products look like in the context of a world where essentially everybody in your company, everybody participating is a programmer. They can program anything, any complex system by instructing it just like you would in a team of engineers, computer science engineers.
Yeah, yeah. And you know, as we embark on our respective journeys, everybody starting from a different place, it's really important to build the right team, because domain expertise, the understanding of the applications and what you're really trying to get to in your process still matters. The pieces don't just fit together without some direction, and building that team with the right people internally as well as externally is important. And that's an additional reason to be excited about this partnership, as two leaders in this space working together and finding new opportunities to add real value in real time is something that we're very excited about.
I think that's a really important point. I can't stress that enough. Up until pretty recently, when people would come up to me and say, what should my child study in college and university? Typically, I tell them computer science, at least as a minor, because no matter what you do, it would be very useful to be able to understand how a computer works and translate what you need into a computer program to help you build tools for that thing. Nowadays, I think that's not good advice. What's more valuable is having that domain experience you're talking about. So I tell them, have them go study materials science or physics, fluid dynamics, pharmaceuticals and medicine, things that are important in the real world around us, and go deep in that, because we're essentially going to have an unlimited number of computer scientists and computer programmers to help you. Of course, there's still going to be a need for computer scientists like me to build the systems that will produce the virtual computer scientists we can all take advantage of. But the value of the domain knowledge is now far greater than the knowledge on how to program a computer, how to build a computing system. That's going to be taken care of for everyone, so we can go deeper into each domain.
Yeah. Still a big role for people as we do create the future, right? So, Rev, very much appreciate the opportunity to spend a few minutes with you today, and for everybody, stay tuned. More to come.
Thank you so much.
Yeah.